Hey, Mrs. Matt here with your Unit 6, Lesson 4 Practice Problems. This is page 32 in your workbook, and you're doing all of numbers 1 through 7. So let's get started. Okay. So number 1, angle ABC measures pi over 3 radians, and the coordinates of C are about 0.5, 0.87. So ABC is this angle here. And it says that the coordinates are approximately 0.5, 0.87. And it measures pi over 3 in radians. The angle itself is pi over 3, and then these are the coordinates. For question A, the measure of angle ABD is 2 pi over 3. So ABD, this one is 2 pi over 3. So if we think about the coordinates of that point, these right triangles, if I make a right triangle to figure out the x and the y coordinate there, compared to the right triangle that we would use here, they should be congruent. So this x value is the same length as this one. However, because it's in quadrant 2, x is negative. So instead of 0.5, it's negative 0.5 for x. And then these legs are also congruent to each other. And this quadrant, the y value is positive. So this has a length of 0.87, so does this one, and it's also positive. Okay, so that's for A. And then for B, ABE, so over to here, the angle that ends there, is 5 pi over 3. So same idea, it's directly below pi over 3. So the x is on the positive side for x, so 0.5. And then the y, this is the same length as that one, but it's on the negative side for y, so negative 0.87. Okay. For number 2, I'm actually going to use the unit circle that we labeled today. And so, let's see if I can get it all on the screen. Maybe if I zoom out a little bit, kind of get it all on the screen. Well, maybe I won't worry about it too much. Okay. So for the first one, we're going to give an angle of rotation centered at the origin that sends point P to a location whose xy coordinates satisfy the given conditions. So let's remember that this is 0 and that angles are going to go, positive angles are going to go in that direction. So we want to land first in an area where x is greater than 0 and y is less than 0. What that means is the x coordinate is a positive number and the y coordinate is a negative number. So that's going to happen down in quadrant number 4. That's where x is positive and y is negative. So looking here, you can pick any of these angles down here. You have 3 here labeled to choose from. Any of those angles in quadrant 4 have a positive x and a negative y. I know we haven't filled in these values yet because there's special numbers we're going to put there, so don't fill them in. But just know whatever x is, it's positive, whatever y is, it's negative. So I'm just going to choose this one, 7 pi over 4. Okay. For the second one, x is less than 0, so a negative number, and y is greater than 0, so a positive number. Oh, I'm going to label, this was quadrant 4. X is negative and y is positive in this quadrant, quadrant 2. So just remember the quadrants go 1, 2, 3, and 4. So x is negative, y is positive in quadrant 2 here. So on the unit circle, you can choose any of these angles as an answer for part B. So I'm going to do 5 pi over 6. And then finally, part C, where y is less than 0, so negative, and x is also less than 0, so negative. So negative x and negative y, that's down in quadrant number 3. We have a negative x and negative y, so you can choose any of these angles. I'm going to do 4 pi over 3. Okay. Number 3, Lynn calculates 0.97 squared. These are some estimates that we got on the activity we did yesterday. 0.97 squared plus 0.26 squared, and finds that it is 1.0085. Explain why 0.97, 0.26 is not on the unit circle. So remember back to the unit circle, we found some coordinates we were estimating, knowing that this point here was at 0, 0. The hypotenuse is 1 because the radius of the unit circle is 1. So if this point was on the unit circle, this length would be 0.97 and this would be 0.26. So with our right angle being right here, the Pythagorean theorem tells us that if this is a right triangle, then a squared plus b squared equals c squared. So if we know that the hypotenuse would have to be 1 since that's the radius, and 0.97 squared plus 0.26 squared equals this, it means it does not equal 1 squared, which it would have to equal 1 squared to actually make that a true right triangle. And so the radius is not this length. If these are exact measurements, this length is actually slightly more than 1 because this is slightly more than 1 squared. So, but is it a good estimate? I would say yes. I would say it's a great estimate because 1.0085 is very close to 1. So it's not that bad. Okay. Number 4. Number 4 was a little bit confusing, so I drew a diagram to help me with it. And I just I often will like trace a diagram that I see through the paper. So this is a great one here. I just need a unit circle. Look at that. You can just trace right through that paper. It's not too bad. Okay. So the x coordinate of a point P on the circle is 0. So the x coordinate is 0. So there's only a couple places where the x coordinate is 0. So if this is a unit circle, the radius is 1. This point right here is 1, 0. And I think that's where we're starting. If point P is the result of rotating the point 1, 0 by theta radians counterclockwise, so in this direction, about the origin, what angle could theta represent? Select all that apply. So it's starting here. So this point up here is at 0, 1. This one is at negative 1, 0. And this one is at 0, negative 1. So if we're starting here to right here, we have an x coordinate of 0. This is pi over 2. So that's here. And then all the way to there, we have an x coordinate of 0 again. And this is 3 pi over 2, which is here. For the ones that we didn't circle, for 0, which would be here, for pi, which would be here, and for 2 pi, which is same place over here. It does have a coordinate of 0, but it's not an x coordinate, it's a y coordinate, so that's why we didn't circle those. All right, number 5. Okay, so when I was working on this one, I thought it would be a good idea because I'm doing all of this comparison, but none of these sides are labeled with anything. So I'm just going to go ahead and do that. Opposite sides get the lowercase letter of the angle because it just will help me make some ratios and be able to compare. Okay. So first of all, so here's angle A. So is this true? The sine of A is greater than 1. So the sine of A would be equal to the opposite over the hypotenuse, A over C. Okay, and in this fraction, this is the larger value. So this is going to be less than 1, not greater than 1. Okay, next is the tangent of A. The tangent of A, I should have used a capital A up here. The tangent of A is equal to A over B. In this fraction, this is the larger number again. You can see B is larger, side B is larger than side A. And so this is less than 1, which is what this says. So yes for B. Okay, next is the cosine of A is less than 1. So for the cosine of A, it's this side B over side C. And in a right triangle, the hypotenuse is always the largest side. So this is the larger number, which means this fraction, no matter what the values are, it is less than 1. And that's what this says, so yes. Okay, next, sine A is less than sine B. Okay, so we already have sine A up here. Sine B, the sine of angle B, is equal to its opposite over the hypotenuse. So B over C, side B over side C. So when I compare these fractions, those are the same. And I know that side B, this is a larger number than that because you can tell it's a longer side. So altogether, this is going to be the larger one. So what does it say? Sine A is less than sine B. So yes, that's true because sine B is larger. Okay, this one is comparing cosine A with cosine B. So I think that gives us the opposite ratios. We have cosine A right here, which is the same as sine B. Cosine B is going to equal its adjacent over the hypotenuse, A over C. So we have the same ratio in these problems. See, we have the same ratio. We already have shown that this is the larger value. So the cosine of A is not less than the cosine of B, it's greater. So E is not a correct answer. And then finally, we're going to compare the tangent of A with the tangent of B. I'm going to rewrite it down here at the bottom. The tangent of A is equal to A over B. The tangent of B is equal to B over A. Okay, the larger leg is leg B. So these use the same legs, just in reverse order. So the larger number for tangent of A is on the bottom, but for tangent of B is on the top. So that means that the tangent of B is the larger overall value. So the tangent of A is less than the tangent of B because this is the larger value. So F is a correct response. Okay, number 6. Angle POQ, this one right here, measures 1 radian. The radius of the circle is 1 unit. What is the length of arc PQ? So this arc, so an arc has the same measure in radians as its central angle. So if this is 1 radian, then the arc is also 1 radian. Okay, and so the answer here is 1 radian. Explain why the length of arc PQ is less than 1/6 of the full circle. So this 1/6 of the full circle is what we want to focus on. 1/6 of the full circle. So the full circle, remember, is 2 pi. So 1/6 of 2 pi is equal to, just multiply them, 2 pi over 6, which reduces to pi over 3. Okay, so on my calculator, I can evaluate pi over 3. So second, and the power button is how you get pi. Divide by 3, 1.047. So this is about 1.047. So 1/6 of the full circle is about 1.047, which is slightly more than this arc, which has a radian of 1. So since 1 is the length of the arc, it is less than 1.047, which is 1/6 of the entire circle. All right, last problem. Okay, for this last problem, I'm going to use my unit circle again and put some points on the circle, on this circle. So Q is the image of P. So P is right here at 0. And let's just remember we have some known measures. This is pi. This is pi over 2. And this is 3 pi over 2. Okay. So first we're going to put a Q on the circle after an 11 pi over 6 rotation with the center here at 0. And so 11, if you look down here, 11 pi over 6, so it's going to be all the way into the 4th quadrant. And I'm going to estimate, it's like 1/3 of this space. So I'm going to estimate Q to be right about here. Next is R, which is 3 pi over 2. We already labeled that. So this point right here is R. 2 pi over 3. So 2 pi over 3 is in quadrant 2. It's 1/3 of the way from pi over 2 to pi. So 2 pi over 3, 1/3 of the way there. Okay, so 1/3 of the way from pi over 2 to pi is about right here. And this is U. And then finally V, which is pi over 3 rotation. So pi over 3 is in quadrant 1. It's like 0, pi over 6, pi over 3, pi over 2. They're each like 1/3. So it's 1/3 of pi from, or 1/3 of this quadrant from the 90-degree or pi over 2 angle. So quadrant 1, about 1/3 of the way from pi over 2 back down to 0. And that is point V. Okay, so that was the end of the assignment. I'm going to just leave this unit circle here for, you can pause. If you didn't get all of the measurements, degrees and radians in that unit circle correctly, take the time right now to do that and make sure there's nothing else on your unit circle at this point. All right, I hope you found this video helpful.